My name is Sergei Izrailev. I work at Integral Ad Science. And next time I'll choose a shorter title because this one didn't fit anywhere and got cut off. So I'll be talking about how humans and non-humans interact with digital ads. I'll start with a little bit about what we do and our data and technology, and then go into how do we distinguish between humans and non-humans online, and then talk about human interaction and what we can do with it. So digital advertising. So if you're a company, you developed your product, you spent a lot of time and effort doing that, and then you want to tell the world about it. You go and, let's say, you buy TV, maybe you buy advertising online. Online, however, it turns out that things are not very clean always. So in general, in advertising, what you have is you develop your marketing message, you know your audience, and then the remaining piece is the environment in which you deliver this message. And basically, this is what we care about the most. We also can measure the impact of the ads in a causal fashion. I'll talk about it later. So in general, Integral helps brands make sure that their message is heard. We do it by establishing a baseline where essentially we want to eliminate everything that has no chance of making an impact, and also protect the brand. So the first thing is brand safety. Airlines don't like to show ads on pages that talk about airplane crashes. Nobody should be advertising on illegal download sites. Actually, people get sued for that. Fraud detection. There are bots out there that make money off of advertisers. Essentially, well, and I'll talk about that in detail later. We also worry about geography. So if you sell a product in one country, you probably don't care about people seeing your ads elsewhere. And then finally, did anybody even see the ad? And if you don't see the ad, then, well, it cannot affect you. So we take this as a baseline that you shouldn't be doing that. You shouldn't be buying ads that that have no chance of affecting anybody. And then we take it further about quality of the pages. Maybe there's too many ads on the page. Maybe the content is not very high quality, and so on. But I'm not going to talk about that and move on to just how our data is used. So we do it in. We use the data in several different ways. So first of all is reporting. So we tell you what happened, and then once people see what happened, they typically want to change that because of all the reasons I just mentioned. So one of the technologies we have is that we can block the ad from ever reaching a page that's not safe for a brand, or if it's a fraudulent impression. Then the brand doesn't pay for the ad, but then somebody already paid for it, right? Because somebody executed the transaction and money exchanged place, exchanged hands, and somebody got paid. So buyers need to be able to optimize what they're buying and need to stay away from the bad places. And then the sellers also want to be able to say, look, my inventory is good, and here is a package that I give to you for a little bit of higher price. So all of this is pretty complex, and therefore our stack is pretty extensive as well. This is not all of it. So we use JavaScript to measure things in the browser, and also it's our front end. We use Java for real-time serving. So when the browser, in-browser data is collected, it's sent to a server, the server has to respond, and it happens many times in a session. We use Storm and Kafka for in-stream processing. the full Hadoop stack, and Impala MySQL for backend of reporting, and R, Python, and H2O for analytics and machine learning. So let's talk about fraud a little bit, ad fraud specifically. So what happens is maybe you download a software that claims to clean up your computer, MacKeeper. Maybe you got on a page accidentally, which I have a couple of times in the past month, where you type in a URL and you make a typo, and it flashes red, and there is sirens, and like your computer is infected. Call this number or download this software, will help you. Don't. So this is how malware gets on your computer, and then what it will do, besides maybe stealing your personal information, it can also browse the web, and you will never know that it is happening, because the pages that it visits never show on your screen. It can be off screen, can be behind, and basically what it does, it's generating traffic for which somebody is paying, but the user of the computer may not even be aware of it. There are other ways that ad fraud is committed. So ad stacking is when there is one ad on the page, but then there's 20 ads behind it. Of course, nobody can see them. And then pixel stuffing is when the whole ad, and maybe dozens of ads, are stuffed in a one-by-one pixel. So it's also possible. So to give you an idea of how we look for bots, we compare the human traffic with general traffic and try to find patterns. So humans, all of us, when we browse, we go to certain sites. It's a reasonable frequency, for example, and everybody goes to their own set of sites, but we never visit places that are fraudulent sites, like nothingtoseehere.com. And also, interestingly, the names of the domains, you can almost tell by the name of the domain that it's a fraudulent site. Whereas bots, they have to make money, right? So they have to visit those sites a lot more, like very frequently. And so by looking at the differences in these traffic patterns, we were able to determine which machines are infected and which sites are maybe fraudulent. Okay, so all of this detection happens at different timescales. First of all, of course, we have a lot of data. We process billions of impressions every day. And so we have a lot of traffic. We know, and we do it in batch, right? So in this way, we flag machines, and we flag sites, use Hadoop for that, and generate basically lists of bad machines and bad sites. However, bots appear faster than every day, which is the batch processing. Typically is once a day. So what we also do is we used Storm and Kafka to apply a simpler model, maybe not as accurate, but it's faster to turn around and to inform the real-time engines that are responding to every impression hundreds of thousands of times a second sometimes, that something is a bot. And then finally, when our JavaScript runs in the browser, we can sometimes tell it's not a real browser by basically probing the browser itself and figuring out that we are being misled by the page. So we combine all of that, and again, part of the solution is to block those impressions, and ads are never shown never reach the page. What we do is instead, basically, there is a blank space. Sometimes there is a public service announcement, but typically it's just blank. So what about humans? So humans, of course, interact with the page in many different ways, right? So you move your mouse, you look at it, of course, you scroll. So there are different interactions that go on. And the question is, what are the metrics that are interesting and that would tell you something about whether or not your advertising actually makes any difference? So first, let's talk about something that may not be so useful, and it's a mouse hover rate. So basically, you have an ad, and you can measure if a mouse crossed the ad, and the question is it a useful metric? So what we did, we compared the mouse hover rates for the same placements in cases when we blocked the ad, so there is nothing there, and when there was an ad. And it turns out that basically there is no dependency, right? So it doesn't matter if there was an ad or there wasn't an ad. In fact, if we compare the fraud rate on those, when we block, the fraud rate, or the mouse hover rate on the fraudulent traffic is higher, because what happens is because people still buy click-through rates. I don't know why, but they do, because it has nothing to do with actually purchase behavior. So bots are really good at emulating things on which people optimized. So if you optimize on mouse hover rate, it actually is a proxy. It is correlated with click-through rate, and so you will probably be getting more fraud than normal. So viewability. It's a term that came up maybe a couple of years ago. To some degree, all of a sudden, after 10 years of digital advertising, people realized, oh, wait a second, my ads may not be in view. And so, for example, on this page, you have to scroll down, and there is an ad at the very bottom. So initially, it was not in view, now it's in view. And we can measure that. We are an independent third party. We don't buy or sell ads. So we come in and tell, OK, so this ad was, in fact, in view. So then that information can be used to transact. And actually, people do transact on that. Basically, people can say, OK, I'm not going to pay for non-viewable ads. And we kind of provide the information that was it, in fact, viewable or not. So, OK, fine. So the standard for viewability right now, industry-wide, this is what there is a body called MRC, that Media Rating Council, that came up with this standard, which is if half of the ad is in view for 1 second, it is considered in view. So great, but is it enough? Like, is it enough to change anybody's mind? And how can we tell? So let's see an example of a billboard. The billboard is standing by the highway, of course, and is it important if there is a lot of traffic on the highway? Is it important how often the same people go there? And is it important how many times they go back and forth? So if somebody is driving at a high speed, they just may not be even looking at the billboard, because you're hopefully looking at the road most of the time. However, if you're stuck in traffic, your eyes wander and you see the billboards, Route 101. And so, in a similar fashion, the hypothesis that we had is that actually the number of times you see the ad and the length of time you see the ad matter a lot. So how can we tell if something matters? So typically you would do an A/B test, right? So you divide your audience randomly, you flip a coin, and some people get to see the ad and some people get to see a public service announcement. And then you measure the difference in, let's say, conversion rates. However, so one is control, another is treatment. However, frequently, it's very costly. actually, I know of a company that spends 10% of their advertising budget on doing A/B tests. It is expensive. Sometimes there are technical difficulties, and sometimes there are even problems with should we even do this at all? Is it ethical? So we came up, pardon me, we came up with a method. Because we measure is an ad in view or not, we can tell that some people actually were delivered an ad but never saw one because it was out of view the whole time. So we take those people, and that creates our control. And we find people that are statistical twins to those people. So it's not easy because, of course, everything is confounded, and we need to control for a lot of things, but we figured out a way that works reasonably well. And what that creates is basically observational causal estimation. So you do it after the fact. And it's called natural experiments. There is a paper, linked to a paper on the top. So this methodology allows us to see if there is any causal difference between different situations. So let's look at the causal lift for number of ads and length of exposure, and as you expect, more is better. However, what you don't expect is that there is a plateau. Well, you expect that, but it's not obvious that there is a plateau. There is diminishing returns. And even though, yes, the more ads you see, the longer time is probably going to be displayed. Actually, it's not completely just correlated. Both are important. So if you show one long ad, there is no lift. And actually, there is some sort of optimal combination between length and frequency. And people don't do this right now. People limit on frequency. Basically, you can say every person can only see 5 ads, for example. Length of exposure is not implemented in advertising systems. So to summarize, fraud is an ongoing challenge. And with this natural experiment methodology, we're able to tell which metrics are meaningful and which are not. And so the examples that I covered was the mouse hover rate is not maybe such a good metric of measure of engagement, whereas both number and frequency of exposure matter. Thank you.
Are there any questions?
Could you actually talk more about integral products? So if, say, I want to bid on ads, what kind of indicators can you give to a demand service platform?
If you, can you repeat?
So
if you want to what?
If I am buying ads, could you talk about what kind of data elements would Integral provide to a buy-side platform?
To a buy-side platform? Yes. So we provide predictive scores so that you can target higher viewability pages. You can target away from fraudulent impressions. And you can, basically we provide the brand safety of the site. So those are the basic ones.
Any other questions? Okay. Thank you, Sergei.
Thank you.